The way flaps are handled changed between Flow 5 and Exafilla 5. Flaps are now a sort of more dynamic property that enabled a bunch of changes to the analysis. The airfoil flap definition also has an impact on the plane analysis, which I will cover in a future video. Now, to define a flap, you right-click on the airfoil, modify, set flap, or you do it through the foil active foil menu. You can choose between a leading and or trailing edge flap, but let's focus on the trailing edge flaps for now. The hinge position is indicated by the circle, and you can move it with these two fields. This airfoil has a designated hinge position at 75% chord at the bottom surface, so let's set that accordingly. The flap angle is only relevant if you choose to make the deflection permanent by ticking the box below. Doing so modifies the airfoil coordinates directly and does not enable the use of the new flap analysis features. There are situations where you still might want to use this, but that is not the focus of this video. Instead, we leave the box open, click Apply, and Save. And let's add flap to the airfoil's name to distinguish it from the old one. Defining a new analysis now lets us also select the flap angle for the analysis, or the new Type 6 analysis. In this, the angle of attack and Reynolds number are held constant, and the flap angle becomes the analysis variable. Looking at the results, we can see that the polar for no flap deflection is identical to that of the old airfoil with no flap. Besides that, a positive flap deflection, so the flap rotated downwards, increases lift, which is what we expect. The results of the Type 6 analysis are displayed as vertical lines in the other plots, since the angle of attack is held constant. Changing the plot variables to the flap deflection angle instead of the angle of attack, we can also see what we expect. An increase in lift with deflection angle, a decrease in pitching moment, and an increase in drag.